Alright guys, so we were talking about the parametric equation, and we have an example problem that I just made up. So R1t vector has this equation, and RT has this equation. And now we have to question ourselves, well, this is the question, are these two equations the same line? Is it the same line? Well, in order to know if it's the same line, first of all, we have to know if it has the same direction, right? So what are the directions? Well, we gotta look at this and this, because that's the direction of our line. So R1 we have 2, -9, -5, and -9. But R, we have -4, 10, and 18. Now, just looking from the outside point of view, it seems like they have different numbers, so they're not of the same direction. Well, that is not true, because these are apparently parallel. It has the same direction. Because when we multiply this by -2, we get -4, 10, and 18. Therefore, these two have the same direction. Okay, so yeah, it does have the same direction. Now, what's next? Well, we have to question ourselves whether there is a point, this point, because I told you this is the position, if there's a point of 3, 2, 0 in RT. So how do we do that? Well, we can just plug that in over on the RT. So we're gonna we're gonna have this. It's gonna look like that. And with this equation, we can have 3 different equations because we have 3 different variables. So the first equation would be 3 equals 2 plus -t. Cool. Number 2 is 2 equals 3 plus 10t. That's cool. And 3 is 0 equals 5 plus 18t. Okay, well that was pretty cool. And then we have to come up with the values of t, which is going to be 1 equals -4t. So this is -1/4. That is -1 equals 10t. So t equals -1/10. And this t is 18t. So -5/18. Cool. We've got 3 different values of t. So from having an actual value, we can say that yes, this line and this line is the same line. So yeah, that was pretty cool. Then we can go to our next concept. Alright, so the next concept that I'm going to be talking about would be projection. This is the concept that I was having trouble with, and I had to go to my professor to ask some things. So let's just talk about what I learned. Let's say we have 2 vectors, vector v and vector w. Now, vector w is just horizontal, okay? It's not going to be all the time, but for the easy sake, you know, like let's just say it's horizontal. So I'm just gonna say, what the hell is a projection? Well, let's say we have a light. You told me there's a light, okay, on the top. So when this light comes down, we have a shadow over here. So it's going to be directly downwards. So if it's directly down, this is obviously going to be 90 degrees. And it always has to be 90 degrees when we're doing a projection. And this vector right there, that is the projection of V on W. So this is how we write it. Projection of V on W. So yeah, I don't really know where we can use this exactly, but I think with this we can find the angle over here by using it, some equations. So basically, we can try another one. Because I told you it's not always going to be that easy. Let's draw some random vectors. That's vector V, and that's vector W. Now again, I want you to find, that's an ugly W vector. There we go. I want you to find the projection of V on W. Well, there's different ways you can do this. I mean, like you can tilt your head or do random things. But for me, I like to put this again because on the horizontal line. So I draw it again. I would draw it again. That's the W. As you can see, W is longer. So, and that's V right there. So I'm just gonna erase this because it's kind of confusing me. All right. So. Again, it's pretty simple. Think about there's a light over here. Straight down, angle. That is your projection of V, again, big V and then small v underneath on W, all right? And I'm gonna tell you how to find the length of that. Well, that is pretty simple actually. So, I don't know why I just erased that, because I'm pretty dumb. Okay, V, W. Boom. Boom. Okay, so projection of V W equals to V times cosine. Because cosine is hypotenuse over the base right there. So, and also from using the cosine law, we know that times V equals that. Now, if you don't know how to get this, you can watch my cosine law video, and then it shows you how we get there. So now, let's see. How do we get, oh, sorry. V, W, V, W. Cool. Now, how do we get this from this? That's pretty simple. We can just move the W on the other side, which is going to look like this. Boom. And then apparently we have to multiply the unit vector, and over here the unit vector is like W over W. That's the unit vector. So in conclusion, we get projection of the V over W equals to times that. Boom. All right. See you guys later.